So we are going to be in the note packet today. Oh, cutie. Nobody on there. We're going to finish up angles of elevation and angles of depression. And then we're going to get into some reference angles. Your test on this section is going to be a week from tomorrow. Okay? So today we're going to start reference angles. Tomorrow we'll finish up reference angles. Friday we'll hopefully get you probably on the vertical. We're probably going to go vertical whiteboards instead of the individual whiteboards on Friday. Just to get you up and moving and working with people. Tuesday's going to be a quick solve. Then Wednesday's going to be we're going to start the next unit, but then also have time for questions and get stuff answered for that day. And then test the next week, Thursday. Okay? Love it. Next week, Thursday, the homework packet is due, correct. Also, formative corrections due next week, Thursday. Okay? So we had this one problem left over from angles of elevation and angles of depression. I'm going to give you 5 minutes-ish, maybe closer to 4.5 minutes, depending on when I decide to start my 4-minute timer. And I want you to figure out how wide the river is. Okay? Go. So you're standing on top of a 27-meter cliff, and you measure the angles of depression to the banks of a river. Which one is going to go to the far bank? Which angle goes to the far bank of the river? Remember, you're up on high, you're looking down. The 42. Yep. Smaller angle gets you to the farthest away point. So this is 42 degrees, 27 minutes. Which side do you want to find? The horizontal or the diagonal? I want to find the horizontal. Yep. We'll call it X. So the tangent of 42 degrees, 27 minutes is going to be 27 over X. So X then is going to be 27 divided by the tangent of 42 degrees, 27 minutes. Now, you've got two options. One, you can convert 42 degrees, 27 minutes into decimal degrees. Okay? 2, you can forget about the 27 degrees altogether. Okay? One of those is a good idea. One of those is a horrible idea. Okay? All right? Now, I'll give you a third option. A third option, most of you have the TI 30X2S's, this calculator, most common calculator out there. This is kind of a similar type one. We need to go 27, and we need to divide that by the tangent of, what did we say, 42 degrees? Well, on these calculators, there's this wonderful key in row 2, third position, that looks like a degree, a minutes, and a seconds. If you hit that key, up pops all of your degrees, minutes, and seconds terminology. On this particular one that I have, it's under angle. So there's my degree. So I can put my degree symbol in. I can go 27. Then I can put in my minutes symbol. And it does all of the converting for me. Okay. So then that would give me 29.517. Now we've got to make a second triangle. Once again, you're standing there. It's 27 meters there. But this time, now it's 53 degrees, 29 minutes. And you want to find that side. Y. So the tangent, 53 degrees, 29 minutes, is 27 over y. So 27 divided by the tangent of 53 degrees, 29 minutes is 19.991. And then your width of the river is going to be x minus y. And that gives me 9.526 meters. Nearest 10? Okay, so that would be 9.5. Okay?
Why would you subtract the 2 instead of adding?
So you're standing here, okay? I'm going to put it in here. The river is right there. With me? So this triangle would come in here. So the difference between x and y would be that distance up there. That's why. Okay. Let's talk angles in a standard position. Okay. If I draw myself a Cartesian coordinate system, the x-y axes, okay, an angle in standard position, I'm actually going to start with the standard position one. An angle in standard position has 3 parts. The first part is it has a vertex. You've all heard the term vertex of an angle before. It has a vertex. Okay. Then it has something called an initial side. The initial side would run along the positive x-axis. If we're in standard position, the initial side is on the positive x-axis and the vertex is at the origin. Then the third and final part of an angle is you have what is called the terminal side. And that's how your angle is formed. You've got an initial side on the positive x-axis, you've got your vertex at the origin, and then you've got your terminal side somewhere in that rotation. Okay? So the measure of an angle, then, is the amount of rotation from the initial side to the terminal side. We can rotate either clockwise or counterclockwise. Okay? If we are going in a positive or with a positive angle, the rotation then is counterclockwise. If we are going with a negative angle, then our rotation would be clockwise. Badass. In standard position, we have many angles that could stop and have the same terminal side. Because we only get 360 to choose from, but if we go bigger than 360, or we go smaller than negative 360, we have many ones to choose from. So we call those coterminal angles. Those are angles that have the same terminal side. So, for instance, it's more horizontal. There is an angle. Do we all agree with that? Okay. So we could get one angle measure going this way in the positive direction. We could get one angle measured this way in the negative direction. We could get one angle measured by going all the way around in that direction. We could get one angle measured by going all the way around in that direction. And we can continue that on forever and ever and ever and ever. Okay? In both directions. In a positive way, we can keep going. We just go another 360 degrees or another 2 pi radians. In the negative direction, we subtract 360, subtract 2 pi. Okay? We can keep going like that all the way through. Okay? So let's set this up. Let's get actual degrees and radians in here. Negative 150 degrees. Which quadrant is that going to be in? 3? 3? Yep. Closer to the horizontal, closer to the vertical in 3, or right smack dab in the middle. Closer to the horizontal, I would concur. It would be something in the neighborhood of here. So that is negative 150 degrees. If I go in a positive direction, what would this angle be? $210 degrees. Yep. So 210 and negative 150 are coterminal degree measures. I could also go there at 570 degrees. I could also go there at negative 510 degrees. I could also go negative 870 degrees. I could also go 930, 12, negative 1230. Could also go positive 930 degrees. How am I getting those so quickly? Adding 360 or subtracting 360. Exactly. Okay. All of those angles are right here in this brown angle that I have drawn. Okay. They're all right there. Okay. 2 pi over 3 is up here in quadrant number 2. You find me a positive coterminal angle and a negative coterminal angle to go along with that one. For positives, I would go with 8 pi over 3, 14 pi over 3, and 20 pi over 3 as the next 3 positive angles that are coterminal with that. In terms of the negatives, I would go with negative 4 pi over 3, negative 10 pi over 3, and negative 16 pi over 3. What am I adding and subtracting each time there? 6 pi over 3, because 6 pi over 3 is 2 pi. Yeah.
So if you change it to like actual angles for that
If we give it to you in radians, we want answers in radians. If we give it to you in degrees, we want answers in degrees. Yeah. Likewise, if we give it to you in degrees, minutes, seconds, we want answers in DMS too. Whatever we give it to you in the problem, that's up what we want the answer. Okay. Because of this, because of the fact that we have unlimited amount of angle measures for each of the angles that we could possibly have, we need some kind of a system as to how to identify them. Okay? And so what we have here is reference angles. Okay? reference angle is denoted as theta prime, okay? And it is an acute angle formed by the terminal side of a ray, and this is kicker here, and the horizontal axes. So all reference angles come off of the horizontal. I don't remember what I said yesterday. I've seen it 1,000, like 10,000 mistakes. I don't remember what it was. Yesterday we were talking SOHCAHTOA angles. Oh, angles of elevation or angle of depression coming off of the vertical. It was yesterday. This one I see more. So this would be like a 15 or a 16,000 time mistake that I've seen. Okay? Right? So if we find theta in standard position, okay, our reference angle is going to come off of the horizontal. So what we mean by that is, find theta in standard position if the terminal side of the ray goes through the point -3, -2. Well, the point -3, -2 is over and to the left and down, correct? Which means then that that terminal ray is coming through there. That terminal ray is going through the point -3, -2. Actual theta is there, correct? Yeah. But if I want to use some right triangle trig on this, here would be my triangle. This side length here would be 2. This side length here would be 3. Half of you do tangent of 3/2. The other half do tangent of 2/3. Tell me if we get a quadrant 3 angle. Tangent of 2/3 or tangent of 3/2. That's my only two choices here. What you got? Oh, correction. I'm doing the wrong way. Inverse tangent. Sorry. Inverse tangent. I was just saying just regular tangent. My fault. Inverse tangent.
That makes it much better.
You should have gotten 33.69 or 56.31, right? Neither one of those are a quadrant 3 angle, right? Okay, so let's do a little right triangle trig. Theta prime is going to come off of the horizontal. It's going to be, that is going to be my reference angle there. Okay? Which is this angle in my triangle right there. Which means then that the tangent of theta prime is 2/3, which means then that theta prime is the inverse tangent of 2/3. Was that the 33 or was that the 56? 33? Yes? Okay. But that's just this angle right here. So how would I find actual theta then? I'd add 180 to it. Actual theta is going to be my reference angle that I just found plus 180 degrees. So that's going to be, what's that, 213.69?
Yep.
Okay. Now, somewhere in your note packet, you hopefully have enough space to put this in, but you need to just make yourself a little Cartesian coordinate system, because we're going to talk about reference angles in the 4 quadrants. Okay? If you are in quadrant number 1, now remember that in reference angles, they have to be acute, and they come off of the horizontal. So if your angle is in quadrant number 1, it is its own reference angle. Reference angles don't exist in quadrant number 1, because they're just the angles. Okay. When you move over here into quadrant number 2, now your actual theta is going to be 180 degrees minus your reference angle, because in quadrant number 2, this is your reference angle. So you have to come back from 180 degrees. Or if we're flat out mean and we're dealing in radians, it would be pi minus your reference angle.
Did you add 90?
No, because reference angles come off of the horizontal. 90 is the vertical. I mean, this is just something you got to memorize, you know. So, okay. In quadrant number 3, that's like what we just did. So then our reference angle, or excuse me, our actual theta is going to be 180 degrees plus our reference angle, or pi plus our reference angle. In quadrant number 4, our actual theta is going to be 360 degrees minus our reference angle, or 2 pi minus our reference angle. Because in quadrant 4, there's our reference angle. So we've got to come back off of 360. I strongly recommend that you memorize that. Okay? Because that is going to, we're going to use that a lot. This slide right here. We're going to use that a lot. Okay? With that being said, what I would like you to do now is I would like you to find me the reference angles for those 3 angles. 125 degrees is up here. That would be the 125 degrees, which would mean that our reference angle would be 55. 220 degrees is down here, which means my reference angle is going to be 40 degrees. And 310 is there, which means my reference angle is going to be 50 degrees. Questions, comments, concerns, clarifications? Good spot to stop, give you some time to work on some homework. I fully expect you to be working on that homework since that homework packet is due next week, Thursday.